a journey of home renovation and maintenance. Welcome to Maintaining 18. You are observing Kofi removing from the tankless water heater its cover. Hot water flowed, and with much imagination, it's like Shanae Timpishka. It has not been more than a week since plumbers replaced the flow meter when suddenly cold water poured over Adjoa's body, followed by screams. The problem was reported to Kofi with a question. What happened to the hot water? Kofi, with a soft murmur, said, "To Bombo." "What was that?" said Adjoa. To which Kofi said, "La bomba has cooled." Realization of the problem is what this episode of Maintaining 18 reflects on. With the NMAX step-by-step troubleshooting guide in hand, the DIY commenced. 5 steps to be performed. Step 1. Testing electrical connections at the terminal block. This is a 8-prone terminal block. Each is connected to a 40 amp breaker. The voltage coming in should be between 208 and 240. Testing began at L1, which is the rightmost prone in the terminal block. The readings may vary slightly. It is good to make a note of them. Each pair of wires, red and black, should correspond to only one breaker. This test will detect problems with the initial wiring or if the wiring has become loosed over time. Before continuing to the next step, in the previous video detailing maintenance on the tankless water heater, the flow meter was replaced. The flow meter that was taken out was not shown. At the end of this video, it will be shown. The mishap suffered shows why the flow meter should be constructed out of a more durable material such as brass. There are not many options out there, and there are certainly no official brass versions available for this tankless water heater. A mashup version would have to be created. What do you think? Please tell in the comments section. The tests performed at the 8-prone terminal block show a passing results. On to the next set of tests. Cheap lead is better than a good memory. Step 2 is verifying power to the electronic board. To do this, the cover to the board has to be removed. The trim or cover is held in place by 4 screws. At the top of the electronic board are some terminal blocks. They currently have wires plugged in via a housing, which is red, yellow, white, and blue. There's also a fuse to the left. The voltage here should read between 110 and 120. It is important that one of the probe leads are grounded, or the board could be short-circuited and damaged and rendered inoperable. The test passed. Nevertheless, there was one connection which, when tested, failed initially, but when retested, passed. There is also a fuse to the left of the terminal block. If there was something wrong with the fuse, there would be no power to the electronic board. The fuse was tested and the result passing. Step 3. Verifying safety thermostats. This step is to verify that power is going through the safety thermostats. They are insulated, so the probe lead has to be inserted under the insulation and then pushed up in order to gain contact to the electrical circuit. There are 4 of them, and they should all test between 110 and 115 volts. The test needs to be conducted at the top and bottom of the thermostat. In this case, the thermostats all tested with a passing result. Step 4 is verifying the heating elements. For this test, the hot water needs to be on, and there has to be sufficient draw. The recommendation is to turn on a tub spout and maybe a sink faucet. The heating elements work in a series, so starting from the side closer to the electronic board, that heating element will draw 100%. For the second element to draw 100%, the first must draw 100%. For the third element to draw 100%, the second must draw 100%, and so forth. The heat element can also be tested using 2 probe leads. In this case, the voltage would double. In this case, the test showed passing results. An assumption here is that the voltage should be between 220 and 240. The final test is to check the amperage draw from each heating element. The test of the first element resulted in a failing score of between 0.29 and 0.37 amps. The test of the second element showed 32 amps. So did the third and fourth elements. So those elements are functional. The problem, therefore, is with the first element. Keep in mind, the elements activate in a series starting from the first. If the first element is not working properly, it will definitely affect the functionality of the water heater. A continuity test can also be used to verify the heating elements are functional or defective. The test confirms the first heating element is indeed defective and non-functional. The troubleshooting guide did not mention this test. The first heating element has to be replaced. It is indeed defective. However, what is to be done about hot water in the meantime? The unit can be brought back into service. However, it would be like an athlete back on the field with an injury. To bring the unit back into service, albeit at diminished capacity, remove the first element and remove the fourth element. When replacing the elements, the fourth element becomes the first element and the first element becomes the fourth element. A swap. This is critical. The fourth element will not be functioning, therefore power is to be cut to that element from the breaker. If you're currently experiencing this problem, good luck and catch you in the next one.